You hear me? Are you muted? There you are.
Can we hear each other?
Can everybody hear
us? Hey, then everybody can hear us.
Wonderful.
Yeah, welcome back.
Yeah,
Hope everybody had a good quick break and that everybody's having an awesome event so far.
And I wanted to give a hand to the interpreters. This has been wonderful having you here. So thank you for joining. I'm trying to keep up watching it too and remember my ASL from college. So Jesse, what's next?
Next, we are going to bring Ellie in to talk about the CDK8s project, to talk about what it is and what they've been working on. And we have some awesome announcements to make.
Welcome, hi, everyone. Ellie. Hey, Jesse. Hey, Jesse. Hey, Justin. Hi, everyone. So really happy to be here to talk about CDK8s. My name is Eli Polonsky. I'm a software development engineer at AWS, specifically working on the CDK8s project, as you can imagine. And Jesse, do you want to, I have a bunch of slides. You can also kind of interject and, we can have a conversation about them, but do you want to share my screen?
Right, anyone in chat have questions about CDK8s too? Feel free to ask. We'll bring them in and talk about it.
Cool. So as you can see from the title, I didn't bury the lead. This will be the announcement of CDK8's first major version, 1.0. And we'll talk a little bit about what that means and the enhancements we made. But let's first talk and see the whole agenda for this talk. So CDK8s has been around for quite a while now. We've also talked about this at the previous Container Day. But I do always like to start these sessions with a quick overview on what CDK8s actually is and why you should consider using it. We'll then move on to the main event, which is announcing the first major version. We'll see the enhancements we made towards this release and what exactly that means. Following that, we'll talk a little bit about CDK8s with respect to the open source community and specifically the CNCF. And finally, we'll have a dedicated Q&A session kind of to wrap things up. Okay, so what is CDK8s? Or instead of what, I prefer talking about the why. So let's talk about why CDK8s. So why CDK8s? Because authoring Kubernetes manifests can be a rather complicated task. CDK8s aims to make authoring those manifests simpler and more robust. And how does it do that? It does that by leveraging general purpose programming languages and standard software engineering practices. So in general, we've been talking about, infrastructure as code for a few years now, and we're all trying to apply that daily. But to me, it seems like we haven't fully adopted it yet. We still create a lot of specialized domain-specific languages, which are awesome for, simple tasks, but to me always seem to fall short when our systems become more complex. We then create entire tool chains to maintain those DSLs, and in a way, kind of mimicking what has been around for a long time now, which is general purpose programming languages and the ecosystems around them. So let's dive a little deeper into why authoring Kubernetes manifests is hard, or at least harder than it can be. We know that manifests.
I honestly thought that you were going to turn YAML into an acronym of why authoring manifests. I was going with it, and I was like, "This is amazing."
Oh my god, I didn't think of it. I will try it for next time.
This is key right here. That was gold.
Great, yeah.
I was reading it.
Good call. Okay, so let's talk about YAML, yet another markdown language. So we know that YAML is static, right? It doesn't allow for conditionals, variables, loops, in general, kind of control flows and enumerations. This promotes a lot of copy paste and makes manifests kind of error prone and very difficult to change. YAML is also hard to customize since there is no native way to pass inputs to it, right? There's also no native mechanism to publish and consume YAML manifests via some sort of central hub or central package manager. This makes them hard to share and fractures the ecosystem and kind of increases the copy paste throughout in a bigger scale. In addition, manifests are they introduce a fairly high cognitive load. Now, this isn't strictly unique to YAML. The load comes from the vast set of resources and properties that exist in the Kubernetes API. and the fact that sometimes those properties are purely mechanical. They don't necessarily align to the mental model of the users. Let's see an example that will hopefully make that clear. So here's a fairly common scenario for deploying an HTTP server and exposing it behind an ingress. Here are the resources that we need to define in our manifest in order to achieve that. So on the left side, we have a deployment that defines our container. In this case, I think it's an HTTP echo container. We have a service on the middle here to expose that deployment. And we have an ingress to register the service under. Now, this is already quite a bit of code or quite a bit of configuration. But also, let's look at the more problematic and kind of error-prone parts of this manifest. So you can see that this app echo label here is repeated 3 times, right? So 2 times in the actual deployment resource, because that's how pod selection works. You need to define a pod template, and you need to label the deployment with that with those labels. And it's also repeated in the service because the service needs to know which pods to discover and which pods to serve. The container port is repeated twice because the service needs to know which ports to target. And the service port is also repeated twice because the ingress needs to know which service port to route to. Note that in this case, the container port and the service port are the same, but that doesn't have to be this way. And finally, the service name, echo service, is also repeated twice, once in the service, because every resource needs a name in Kubernetes, and once in the ingress, because the ingress needs to know which service to route to. So all in all, there's quite a bit to get wrong here, right? You need to make sure all those strings match, and you need to understand the mechanics of what exactly are pod templates and how do you apply label selectors and everything. Now let's talk about general purpose programming languages and how they can be used to address these issues. So general purpose programming languages, first of all, are dynamic, right? You can use all the variety of control flows and iteration capabilities they have to offer. This makes it easy to keep your manifest dry, i.e. following the don't repeat yourself principle, which we've seen is problematic with YAML and in general is considered kind of a 101 software engineering practice. Every programming language also has its own standard package managers. So we have built-in sharing and consumption mechanisms for the entire ecosystem. And to address the problem of cognitive load, which I mentioned is not strictly specific to YAML, we can also encounter it when we're using code. But with code, we can actually create abstractions, right? And because of the standard package managers, we can also share those abstractions and provide our users with a much more simplified API. So let's see an example, the same example actually, with CDK8s, now in code using TypeScript. So we can see the same set of resources, right? We still have 3 resources. We still need a deployment, and we still need a service and an ingress. But now you can see that they're defined in code. Now, these resource APIs, the kube deployment, the kube service, and kube ingress, these are auto-generated by CDK8s based on the open API specification of the Kubernetes resources. And you can generate them for any Kubernetes version. You can also generate them for custom resource definitions simply on demand. So the structure of this program is basically the same. We create 3 resources, but since this is now code, we can very simply define constants, right? These are the same constants that we talked about that we're repeating all the time during the manifest, and we can just use them whenever we need to. And another cool feature of CDK8s, and also this is just possible because this is code, and it's not like it's not super, it's not super high tech, right? Just the fact that we're migrating or transitioning to code opens up a lot of possibilities that seem simple and native, but are really powerful. So for example, CDK8s will actually auto-generate Kubernetes resource names for you. Remember that those resource names are required, and they have to be unique across the entire manifest. So CDK8s will actually take care of that for you. And you can use those auto-generated names in your manifest when you need to reference them. So for example, here, instead of repeating the service name, we can just assign the service to a constant and then access the name property for that service anywhere we want. And you can imagine how easy it would be to combine this code into reusable components, right? This is just simple class composition, and then share it and publish it through standard package managers. And this composition is also how we create API abstractions and address the problem of cognitive load. Okay, so CDK8s itself offers a set of API abstractions called CDK8s Plus. And let's see an example. Let's see the same example actually using these abstractions that we offer as part of the tool.
So as we transition there, Ellie, so basically the way I see this is exactly how you just laid it out. So we're taking the conceptual knowledge that we have of Kubernetes, which we don't get for free, right? There's no magic here. You have to still understand what you're doing.
Yeah.
But you're shifting from working with YAML, which is not inherently a programming construct or programming language that like lends itself to programming constructs.
There's a big debate. There's a big debate on that, right?
Well, I didn't say it's not a programming language. I was like, wait, maybe I did. So I didn't mean that. But you can actually encapsulate those same concepts in these more modular pieces of code, and then actually import them, extend them, which I think is the real magic here, right?
Exactly. And I want to also emphasize that we've heard people and our customers and users talk about the fact that code is great and abstractions are great, but the flip side of an abstraction, right, is that it kind of it hides certain things from you, and sometimes people want to have the full control over their underlying infrastructure. So the example we saw before, let me just go back for a sec here. So this thing, you can see that the API that this exposes is exactly the same as the YAML one, right? So you don't actually lose anything here. You can still define every single property and resource you want, but you can just do it simpler with code. CDK8s Plus, however, does hide a few things away from you. We'll see that in a bit. And that does mean that you have to kind of, and again, it hides those things, but it doesn't, someone needs to take care of all that complexity, right? So it's either you, the user, or it's the library. And when you use those abstractions, you kind of take a leap of faith, or there's a lot of trust involved here that the library will do the right thing. So these are the kind of pros and cons. But let's look at the CDK8s Plus example, and let's just talk a little bit about what CDK8s Plus is. So CDK8s Plus offers.
Ellie, I just wanted to mention like what Jesse was saying too. I know a lot of people, YAML, like you're learning the API, you're learning what Kubernetes API is, and for me, I remember my very first, I wrote the YAML file. I was like, oh, I deployed it. That was amazing. And then I was like, oh, I want to reuse this. And I just put like environment variables in there. And I use like env substitute and just like bash curl it into like Kubernetes.
That might be what I still do. Like I might still do that quite a lot, just saying. And I might wrap it up in make files because I'm that terrible a person. Yeah. Okay.
You're not you're not alone here. I used to do this a lot. Not just with Kubernetes manifests. Every single configuration file that I ever had basically turned into some sort of templating.
Right, and that's how like the Kubernetes ecosystem has grown from that. Where originally it was static manifest, but your point early on, like there is no Kubernetes manifest hub. Like I can't go like just download someone else's stuff. Like I need to template that somehow. And like beyond that is essentially what Helm is doing, right? We have Go templating in Helm. I've written plenty of Helm charts in my time, which is essentially the same thing. It's just instead of the pretty inflexible environment substitute command, I'm using Go and templates that can do things like same defaults, and I don't need to export everything as like an environment variable. I can get a file and it merges. Like there's some benefits there of Helm. I can reuse a template from someone. Those get published. There is a Helm repository for those things where I can just take all those substitutions. I know what values I want and then deploy those things as well. And CDK is different, where we're not just wrapping the YAML with new ways to substitute values. We're taking a programming language with all the tooling of that language. If you're using, Python, you can do tests. And then we're generating YAML from that. And so we're taking a code first approach to generate the YAML versus replace a bunch of variables in something that is static.
Exactly. I couldn't have said it better. Definitely. I think that the tools like Helm do a great job with this, but again, there's an entire toolchain around them, right? There's for programming language, we already know this stuff. We already know how to publish packages and how to consume them and how to declare dependencies and how to import them. So this is kind of what we've been doing all along. So why not do it also with these infrastructure needs? And we've been talking about infrastructure as code, and let's start talking about infrastructure is code, right? And if infrastructure is code, then let's use code to define it.
Right.
And I think
Sorry, one quick question just from the chat here about CDK versus Helm. And CDK is the cloud development kit from Amazon. So if you're used to using Terraform or CloudFormation to create AWS resources, the CDK allows you to do that with code exactly the same way that CDK8s is doing that with manifest, YAML manifest. So you're doing the same process, different sort of resources and APIs you're dealing with.
Exactly. And actually the CDK for Kubernetes was kind of born from our experience with the AWS CDK, and it uses the same underlying technologies, whether it's the construct programming model or JSII to do the transliteration for programming languages. So it's definitely in the same domain. But yeah, CDK is specific to AWS resources. CDK8s is about authoring Kubernetes manifests. Okay, so let's take a look at this example, right? So this is the same thing. This is the same exact manifest that we defined before, but all we need to do here is we define a deployment resource. We don't necessarily know how the deployment resource is structured, but what we do know is that we want that deployment to deploy a container. That is our intent, and that's why we commonly refer to CDK8s plus APIs as intent-based. So we interpret the user's intent, and then we perform the underlying mechanics that we need in order to make that happen. So here we create a deployment, we define a container, we then expose that deployment via service using semantic APIs, right? This expose via service method is exactly kind of the semantic that I'm targeting. And it's very similar. It's actually the same as running kubectl expose. And then we use that service and we define an ingress rule using that service. So these 10 lines of codes will generate the exact same manifest, but in a much more concise and intent manner. Okay, so now we can finally define kind of what CDK8s is, right? CDK8s is an open source multi-language software development kit for modeling Kubernetes resources as reusable components. So it lets you employ standard software engineering practices, cut and copy paste, and go from code to config that can run anywhere. And that's an important point that we've had a few of our customers mention, that CDK8s will generate pure Kubernetes manifest. They're not in any way tied to Amazon EKS or any other provider, right? They generate the manifest, and we actually, as CDK8s, intentionally don't handle the deployment aspect of it. We're an authoring tool, right? So we help you author the manifest, and from that point onward, you can take it and deploy it, whether it's kubectl or GitOps or whatever other way you see fit on any cluster. And CDK8s currently supports Python, JavaScript, TypeScript, and Java, and Golang is coming soon. Okay, so this is the main event. Yeah, woo! So CDK8s finally gets its first major version. I'm really happy to announce that. We know that it's not easy to fully adopt a tool before it has those compatibility support that comes with a major version, especially with big enterprise or projects that require a lot of infrastructure. So let's see exactly what this means and what are the enhancements we made with this release. So first, let's talk about the CDK8 CLI. So the CLI has three main commands. So it has CDK8s init, which kind of creates the scaffolding for your CDK8s project. This is just a normal idiomatic project based on your preferred programming language. It just helps you get started. Then there's CDK8s import, which is what I mentioned before. It's the command that actually auto-generates code bindings based on API specification, whether it's the core Kubernetes resources or custom resource definitions. So and the third one,
you can import a CRD, any CRD you can import, you get that spec automatically, and then you can build your CDK, your code to generate the YAML.
Exactly. You get the bindings for that CRD, you initialize it, you pass your inputs, and then you synthesize and get your manifest. So, and then the CDK8 synth command is what actually produces the final manifest. Now, this is a CLI command, but you can also do this programmatically if you want using the CDK8s API. So starting with this release, all of this functionality and API will remain stable, at least until the next major version, right? Okay, so CDK8's core is the second component, is the foundational API that everything else is kind of built upon. It was a silent participant in our slides, but it's actually very important. So this isn't the generated code bindings, right? The generated code bindings are on-demand code that we generate. This CDK8's core API is lower level and actually is used for a few features. And one of them, we've seen one of them, which is the auto generation of Kubernetes resource names, right? This is something that the core API does. There's also Helm support, escape hatching, resource dependencies, a bunch of these stuff that's needed to orchestrate your manifest, but that's not tied to a specific resource. So again, this also gets the 1.0 mark, and all its APIs are expected to be stable going forward. Now, what about CDK8s Plus? So CDK8s Plus, we decided to keep these APIs right now in beta a little while longer, as we gather more feedback from the community. Like I mentioned before, these APIs are the abstraction layer, right? And with any abstraction, it requires from the user kind of a delegation of trust, and trust needs to be earned. So we wanna bake these APIs a little while longer, work with the community, and make sure that we're covering our bases here. Having said that, we totally intend on graduating CDK8s Plus in the near-term roadmap. This is very important to us, and we're very eager for any community feedback here. It'll make this process a lot faster. Okay, so let's talk a little bit about some enhancements we made. So I said a few slides back that Golang is coming soon. Well, here it is. I think that was the fastest release ever, 30 seconds or something. So Golang is now officially supported with CDK8s. It has been by far our most asked for language. We acknowledge, the prominent role Golang plays, and especially in the Kubernetes and the container community. So Go developers can now use this awesome language to define both their application code as well as any Kubernetes infrastructure needs. Special shout out goes to the maintainers of the JSII project, which makes this all possible. I mentioned this before. This is the underlying technology that also powers the multi-language support for the AWS CDK and actually for the CDK for Terraform as well. Note that Golang support in JSI is still in developer preview. You can track the support for Golang in the JSI repo. Okay, so CDK8s Plus for multiple Kubernetes versions. This is also something that we decided to add with this release. Even though we're not graduating CDK8s Plus, we are paying attention to it. And one very common thing that we've been trying to deal with is how do we support CDK8s Plus for multiple Kubernetes versions? The lower level APIs, the ones that are auto-generated, that's not a problem, right? Because those APIs are just generated on demand. You can specify which Kubernetes version you want, and CDK8s will generate the code bindings for that version. But CDK8s Plus APIs are handcrafted. Like we write them, right? The community writes them. And when we write them, we need to be aware of which Kubernetes version we're targeting. So let's see what kind of problems that will arise, and that'll give you a better understanding of the solution we decided to take here. So this is the code we saw before, right? This is the CDK8s Plus code that defines our manifest. When we were writing this code, we, as me, as a user, as a consumer, I was operating, let's say, Kubernetes version 1.21. And we were using the V1 beta 1 version of the Ingress resource, right? Because in that Kubernetes version, that resource exists. So what happens now if I decide to upgrade my Kubernetes version to 122 and I synthesize the same CDK8s application and I get the same manifest? Well, for those of you keeping up with Kubernetes releases, the Ingress resource has actually graduated to stable a few versions back. And in 122, the V1 beta 1 version of the Ingress resource no longer exists. So this means that if we try to deploy the same manifest on our new Kubernetes version, it'll fail. So we definitely need to perform some sort of code change here. And that makes sense because Kubernetes, according to their SLA, did a breaking change of sort. So from our perspective as CDK8s plus authors and maintainers, one option would be to simply replace the Ingress V1 beta 1 resource with the stable version, and let it compile. That's not a good option, right? Because that means that we're performing a breaking change here. We're performing a breaking change, and we're also making the library basically unusable for users who still want to use the V1 beta 1 resource for their own reasons. Another option would be to add a new stable Ingress resource to the same library so that we'll have both V1 beta 1 and the new stable resource, and then users can choose to migrate whenever they want to. The problem with that is that now CDK8s Plus will expose two different versions of the Ingress resource. And depending on what Kubernetes version you're actually targeting, both of them may fail at some scenarios. That's not a good experience. One of the main goals or tenets of CDK8s Plus is that if your program compiles, then it should also deploy. And definitely if your program synthesizes, then it should also deploy. So we don't want to expose users to any capabilities that they might discover are not available in their target cluster. So does that make sense? Okay, let's see. Oops, sorry. Let's see what did we decide to do here. So the solution we came up with is actually to vend a different version of CDK8s Plus for every Kubernetes version out there, right? So instead of using CDK8s, so before we used to use CDK8s Plus 21, and now we're using CDK8s Plus 22. And notice what happened when we upgraded this dependency, right? And remember, we're in code. All we do is upgrade a dependency in our package JSON file or something. When this dependency was upgraded, suddenly we get a compile time error because that resource is not available anymore. And this is great. This is exactly what I wanted to happen because I'm now aware of the Kubernetes change, and I don't even have to deploy and get an error to see what I need to fix. So I know that all I need to do is change from the Ingress V1 beta 1 to the stable Ingress resource, right? And in CDK8s Plus 22, that Ingress resource is available. And in CDK8s 21, the earlier version is available. So users can choose which CDK8s Plus version or which CDK8s Plus package to use based on their target Kubernetes version. Let's see an example here of something even cooler, I think. So this is the same code, right? This is the same code as, it produces the same manifest, but in a simpler way. And notice that here, all we do is create a deployment, and then we call the expose via ingress method. That's it, right? And this method is a representation of our intent. Remember, all we wanted to do in the beginning was create a container and expose it with a specific path, right? That's it. So when we do that, when we switch over to 122, we actually don't have to do anything because we didn't actually use the Ingress resource. It was created for us by CDK8s Plus, and it will continue to do so, but with the correct resource. So when we change from CDK8s Plus 21 to 22, we actually bypass this breaking change altogether, and we don't need to perform any changes to our manifest. So
at that point, the important thing is to match your library, whatever version of CDK8s Plus you're importing, with the version of the cluster you're going to deploy to, right?
Yeah,
so
exactly.
You don't have to change the code, but you have to change the library to say, oh,
exactly.
the cluster,
you still have to change.
Cluster.
Yeah, you still have to change the dependency, but that's it.
Yeah.
And if that's not it, then the compiler will tell you.
Right.
Right. So CDK8s Plus will be maintained for the 3 latest versions of Kubernetes. As of now, these are 22, 21, and 20. It's a little hard to kind of grasp. We have an FAQ. What are the differences between them? When you should use each one? So make sure you check that out. Okay. Let's talk a little bit about the community. So CDK8s has been developed as an open source project from day one, right? It was really important for us to form a community and get community feedback, because this is the shaping of these APIs really need to be, battle tested. And we're actually continuing our open source engagement by coordinating with the CNCF, which I want to talk a little bit more about. So CNCF, our journey kind of with CNCF, we released CDK8s as part of AWS Labs. We were then accepted to the CNCF sandbox and moved CDK8s to a dedicated CDK8s team organization. We also recently completed CNCF onboarding, which is a bunch of boring logistical stuff. But the reason I mention it is because we're highly engaged with it, and we're really looking forward to continue working with the CNCF as far as developing an open governance model and gearing up towards incubation and moving forward. All right, so that's it. I think maybe we have some time for Q&A. I'm not sure.
We are almost out of time for this session. There was one very relevant and also great transition into the next talk from AK here.
This is perfect.
Right, can you combine CDK and CDK? So CDK, cloud development kits, I want to provision AWS resources. CDK8s, I want to use those resources inside of my Kubernetes cluster.
This is perfect. Yeah, we actually have a native integration for the AWS CDK with CDK8s. You can define an application that depends on both of them. You can use CDK8s to author your Kubernetes manifest, and you can use the provisioning capabilities of the AWS CDK to deploy an EKS container and then apply your manifests to it. I'll be happy to share some more resources with that. I actually did a reInvent talk last year around this specific area and kind of showing how that can be done. But yeah, definitely good question and a good use case, super possible and super intentional by us.
And to the point of, doing it in the CDK8s combination all in code is a great way to combine those resources. Our next session about ACK actually addresses that in like a slightly different model, where if you want to manage the state of those resources directly inside of Kubernetes with controllers, you can do that with the ACK. So we're going to talk about that piece just next. I think that was most of the questions. Oh, one other question I saw come in, unit testing, because that is one of the big benefits of doing code.
Yeah, excellent question. So we do have some facilities for unit testing, mainly in TypeScript at the moment, but we are actually working on providing an assertions library for all the supported languages. This is also kind of tied with the work we're doing with the AWS CDK around this matter. So definitely unit testing is in our roadmap, and you can also see examples kind of in our repo. How do we unit test our own manifests? So definitely we're planning on enhancing that capability.
Cool. Thank you, Ellie. Thanks so much. And congratulations to you and the
Thanks,
team
Justin.
on 1.0.
Thank you.
Awesome.